Hi students, today's topic is electrostatic and we are going to see the charging by friction. As you all know that all matter is made up of atoms. An atom has the same number of electrons in its orbits, which are negatively charged particles, and at the nucleus we have positively charged protons and neutral neutrons. The electrons, as we have said, has negative charges and the protons have positive charges. In nature, we have two types of charges, negative and positive. And the like charges repel each other. That means that negative charges repel each other and positive charges repel each other. While unlike charges attract each other, a positive and a negative charge attract each other. While here also the charged objects attract neutral objects. For example, if we have a negatively charged and neutral object, then this negative charge will attract the neutral object. Also, a positive charge will attract a neutral object. Let's make an example. We have the spheres K, L, and M suspended by light strings. They are in equilibrium as in the figure. What are the possibilities of the sign of their charges? Now we see that K and L repel each other. So K and L should have same sign of charges. So if K is positive, then L should be positive. If K is negative, then L should be negative. There is an attraction between L and M, so they are unlike charges. So if L is positive, then M should be negative. If L is negative, then M could be positive. Also, we know that the charged particles attract neutral objects. So if L is positive, then M may be neutral. If L is negative, then M may be neutral. Now let's see the charging by friction. The only reason that we are able to use electricity in our modern world is that it's possible to separate positive and negative charges from each other. One way to do this is by rubbing two different materials together, which we call the process as charging by friction. Since the two objects are made of different materials, their atoms will hold on to their electrons with different strengths. As they pass over each other, the electrons with weaker bonds will be ripped off that material and collect on the other material. Let's explain this with an example. When we rub a piece of ebonite, which is a very hard black rubber, across a piece of animal fur, the fur has the ability to lose electron and ebonite rod has the ability to gain electron. So the electrons will be rubbed or passed from the fur to the ebonite. So the animal fur has lost electrons, so the losing electron will be positively charged, and the ebonite rod has gained electrons, so it will be gained negatively charged. We have another example. When we rub a glass rod with a piece of silk, now here the silk has the ability to gain electron and glass rod has the ability to lose electron. So the glass rod will lose electrons, so will be positively charged, and the silk gaining electron will be negatively charged. Rather than try to keep track of all the combinations, we can arrange some of the more common possibilities in a chart called electrostatic series that lets you find out which material will be positive and which one will be negative. Here you see an electrostatic series charge. Now, when you go down, there's an increased tendency in losing electrons, and when you go up, there's an increased tendency to hold on to electrons. So I can say that, for example, sulfur has more tendency to hold electrons than silk, or lead has more tendency to lose electrons than copper. Now let's do an example depending on the electrostatic series. Determine the charge on a piece of copper if you rub it to a piece of silk, looking at the electrostatic series. Now, when I look to the copper and the silk, I can see that the silk has less tendency to hold to electrons. So, as it has, the copper has more tendency to hold on electrons. So, silk will lose electron, silk, copper, it will lose electron, so will be positively charged, and the copper will gain electron and will be negatively charged. So here I can say that copper is closer to the top with silk beneath it. This means that copper is negative and silk is positive. Let's do another example. We have two neutral objects. They are rubbed to each other and charged. Decide whether the given statements are true or not. When I rub two objects, let's say A and B, one will lose electrons, so will be positively charged, let's say plus Q. This is positively charged because that means that it has lost minus Q amount of electrons. So B will be charged with an amount of minus Q. The charge is conserved. That means that the total charge before the interaction should be equal to the total charge after the interaction. Before the interaction, they were neutral, so the total charge was zero. So after the interaction, again the total charge should be zero. So the amount of charge of the objects will be equal. The amount you see that are equal, but the sign are different, so this is true. 2. One of the objects will be positively charged by losing electrons. Yes, A is positively charged by losing electrons because the negative charges are carried by the electrons, so this is also true. 3. The sign of charge of the objects will be the same. No, one is positive and the other one is negatively charged. In charging by rubbing, always the objects are charged with opposite sign of charges, so this is false. And the last statement, the amount of charges of the objects will be proportional to their dimensions. It is also false because the amount of charges are equal. It's not important what the dimensions are.